Greetings, let's talk about work a little in this one. So work in general, it is defined as force over distance. That means a particular force is applied for some interval of distance. So let's say the distance is 10 meters and the force is 10 newtons. Then in such case, the work will be 10 newtons times 10 meters as such, and the result will be 100 joules of work. That means in order to do a force of 10 newtons for 10 meters continuously, a work of 100 joules is done through that. Alright, so let's now talk about a little more general example, and this is where I'll wrap it up. And that's basically when there's some mass on the ground pushed. I'm not even talking about any other forces, I'm not talking about any resistance or anything like that. I'm just saying that it's actually pushed, and in a way that there's no loss. It's pushed in this direction, where basically there's an angle between the roof of the mass and the direction from which it is pushed. Let's say it is pushed from this direction, and it is pushed from here at this special angle, and the angle, I will say a concrete one, for example, maybe, or I'll just do the general case, but let's say the force here is 50 newtons, alright? So when I'm talking about such work, well, I want to, for example, find out the work that will be done when this block is pushed along this surface, on this surface, and it's a straight surface going in this direction, which is a different direction than from which it is pushed. It's skewed, pushed. It's not pushed straight in the direction of its travel, but it's pushed from this side, so just a partial component of the entire force vector will actually apply there in this direction, and therefore, let's say it's pushed for 3 meters. So again, the work for such case would be F times S, the force applied times the distance. But the thing is that 50 newtons, when I push it for 3 meters, it won't be 50 newtons in this direction. It is 50 newtons in this direction, but in the horizontal direction, it is just this. It's just a projection. So the entire vector, let's say it starts here and ends here, pushes in this direction, including the direction, but the horizontal component of the vector, so the force, the part of the force that goes only in the direction of the travel, in the one horizontal of the ground on which the block resides and it will slide on, well, that's just the projection below it. And you see there's a perpendicular triangle created from this. So right below the vector there's this also vertical component, so let's say Fy and Fx. So Fx is the one that really creates this work, because I'm talking about just the work in this direction. Alright, so when I'm talking about it moving from here 3 meters, then the work will be actually just the Fx times the 3 meters. Alright, so that won't be the full 50 newtons. And how to calculate just this part? Well, there's this formula multiplied by the cosine of this angle. Alright, so multiplied by the cosine of this angle. So Fx further is equal to the F over the angle, which is not straight. It is applied from this particular angle. It can be any of these possible angles, and that gets multiplied by cosine of the angle under which it is applied, and the angle is basically the difference in direction from the pushing direction versus the straight line in which the object moves. And so this is further multiplied, of course, this is just the force, and that is further multiplied by the 3 meters. Alright, so I can say Fx times 3m, just saying it's this component of the force vector, because the force is this, but it gets broken down into just this vertical component. Is the force that goes on vertically, and the force that goes on horizontally, this one. So Fx further rewritable as the original force from that special angle times the cosine of the angle. That basically only gets this part of it, which is the one really acting in the direction of this travel, in the direction of the work that I'm talking about here, and then times the 3 meters. Alright, so this was also another case in which it is pushed from a different angle than and then the direction in which it actually travels. But the work still can get counted, and this is the way to do it.